Hey, 2018 BC practice test continued. This looks like partial fraction decomposition. So let's see, I'd have a over 1 minus x. It's already factored for us. That's nice. B over 3x minus 5. So 3ax minus 5a plus b minus bx. All right, that's what it would look like. That's got to equal the top of this, the 1 plus 3x. So the x coefficient is coming from 3a minus b, and that must be equal to 3. And then the constant must be coming from trying to kind of match those up. The constant minus 5a plus b must be 1. And look at that. They set it all up. I can just add those together. Minus 2a is equal to 2. So a is negative 1, which means b must be, let's see, if a is negative 1, that would be 5. So b would have to be negative 4. Is that right? See, let me just check and make sure that that works in both of these. No, it does not. Minus 2a. Oh, you know what 3 plus 1 is? It's not 2, it's 4. So that's negative 2. And then b, if that's negative 2, it's negative 6 minus, that'd be 9. I think it would be that. Let's just check that here. So negative 2. Yes, that looks like it would work. It'd have to be negative 9. All right. And if you go back, I mean, at this point, if you're very confident in what you did there, there's the 2 and the 9. So it's going to have to be that answer. Oh no, hold on a second. Wait. Hold the phone. Let's check here what's going on. So negative 2 here, that'd be negative 2 over 1 minus x plus or minus 3x minus 5. So that's the integral that we're trying to do now with this partial fraction decomposition. I can move this stuff around. I could turn that into 2 over x plus 1, x minus 1 rather. And that's a little bit easier for not having to worry about sign issues with the antiderivative and that little natural log issue. Minus 9 over 3x minus 5. So, let's see here. The 2 natural log x minus 1, which is the same as this, right? We have to recognize that. And minus, this would be 9 natural log 3x minus 5, but then I have to divide by the derivative of what's inside, so long as it's a linear factor. So that would be the minus 3 and my little answer key here says that it's A, and I've got something that is certainly very close to that, so maybe that's not true what I just said there. 2 natural log of 1 minus x. So we have to convince ourselves. So if we did it here and did like the negative 2 times the natural log of 1 minus x, but I'd have to divide by that, and that would turn it into. So that's certainly correct. But so is what we did here. So we just want to be able to justify to ourselves that that's the same thing. Well, okay, I think I see what's happening here, or how we can justify this. The natural log of x minus 1, absolute value, is the natural log function shifted over to the right by 1, like this. But it's the absolute value of that inside, which makes it do this. Oh yeah, because sorry, sorry. The absolute value of x minus 1 and the absolute value of 1 minus x is of course the same thing. That's true for any two numbers. 3 minus 2, 2 minus 3. That's always true. Absolute value of a minus b is always equal to the absolute value of b minus a. Sorry to get sort of hung up on that. That's silly. So I think that that's a little bit of a challenging one to land on the right answer, but there you go. That's the right answer. A spherical snowball is melting in such a way that it maintains its shape, which is spherical. The snowball is decreasing in volume at a constant rate of 8 cubic centimeters per hour. So that's dV dt. This is related rates, people. It's decreasing. Cubic centimeters per hour. At what rate in centimeters per hour is the radius of the snowball decreasing at the instant when the radius is 10? Okay, so we're looking for dr dt, and this is the r, right? So they gave us the volume formula just in case we didn't remember that, but of course you did. So dV dt, you're taking the time derivative of this, 4 pi r squared dr dt. All right, looking for dr dt, we should know everything else. So looks like I got negative 8 equal to 4 pi r squared dr dt. So if you divide by 4, that gives us 2. So negative 2 over 100 pi, and then I could have divided by another 2. That's negative 1 over 50 pi. The radius is decreasing at, so they said the decreasing part, so they kind of took care of the negative sign for us. So that's 1 over 50 pi. How about this? If f of x equals this, then f prime, well, what's f prime? This is what's the derivative of this? That's the most easiest calculus question in the world. You just drop that in because derivative and integral cancel each other out. So it's cosine of x to the 6th. But if this is not just an x, you have to multiply by the derivative of what's inside because that's dropping in there. It's a chain rule. So now I just need to plug in the square root of pi into this. So that's going to be cosine of the square root of pi to the 6th is going to be pi cubed times 3 pi. Cosine pi cubed times 3 pi. That looks like d. What's the slope of the line tangent to the polar curve when theta equals this? So to do the slope of a polar curve, we need to do we need to parameterize it. Remember that x is equal to r cosine theta, and y is equal to r sine theta. So dx, well, let me do these first. So x is equal to r is 2 theta squared, cosine theta, and y is equal to 2 theta squared times the sine of theta. So my slope what I need to find is dy d theta over dx d theta, because that's dy dx. Right, the d thetas would cancel. That's how we do that. That's fairly recent for us, right? It's like the last thing we did, polar stuff. So dy d theta is, using the product rule, derivative of the first times the second plus the first times the derivative of the second. And then dx d theta, derivative of the first times the second. I'm going to put a minus sign there because I think it might end up becoming minus. The first times the derivative minus sine theta of the second. So it's that. And then I just need to carefully plug pi into that. So sine of pi is 0. The cosine of pi is -1. So that's going to be negative 2 pi squared over the cosine of pi is -1, so that's 4 pi, -4 pi, and then minus, oh, the sine of pi is 0 again, so those both got knocked out. Oh, I guess those canceled, and so it just comes out to be pi over 2, I guess. We could have simplified a little bit there before we plugged it in if we saw it, but I got the same thing here, pi over 2. All right. Problems like that, that's not super hard, but it takes a little bit of time, so you really need to bank time on other questions. Let g be a twice differentiable increasing function. If g of 0 is 20 and g of 10 is 220, which of the following must be true? Twice differentiable means that the MVT and IVT both apply, right? And it's not a closed interval, so we don't have the extreme value theorem in effect, which says there has to be an absolute maximum or minimum if it's a closed interval, and it only has to be continuous for that. So the intermediate value theorem would say that all of the values, all the y values between 20 and 220 would have to get hit at some point for some t in the interval. But that's not what any of these say. None of these are saying about something in between 20 and 220. The MVT would say that the average slope has to be equal to the actual derivative at some point. So let's see, the average slope would be 220 minus 20 over 10 minus 0, which is 20. So the actual slope has to equal 20 for some t in that interval.